Okay, so today I want to look at how we can solve FRQ 1 and 2 style questions. So we're going to have a look at a functions concept question and a modelling question. To start us off and warm us up, we're having a go at the do now, looking at secant lines. So secant lines have been appearing in our FRQ2 questions every time. And this is the part that you're finding most difficult. So let's try and just look at the basics of this idea so we can get it right. So first up, we have to write down the coordinates of point B, where x is equal to 3. That's pretty easy, this one. So I'm going to start off with f of 3. It's 32 times 1 over 2 to the 3. This gives us 4. So B has the coordinate 3, 4. Find the average rate of change from A to B. So the average rate of change is equal to, we need y2 minus y1 over x2 minus x1, which gives us minus 12 over 2, which is minus 6. The tangent line, the secant line. Make a note of this equation. It comes up in this question. We are going to use the secant lines equation, which is y is equal to y1 plus m bracket x minus x1. This is just a rearrangement of the point slope form of the straight line. We can put in our values. So we need to find the secant lines equation, L of x. So L of x is going to be equal to, and we could use either of these 2 points. It doesn't matter which of these 2 points that we use, we can use either. So I can say 16 plus, well, I'm going to put m in, which is minus 6, so plus negative 6, bracket x, and y1, which one? I use point A. This is the equation of the secant line through AB. You can, if you want, open up the brackets and rearrange this. We open up the brackets here on this one, we're going to get minus 6x plus 22. In what interval is L of x greater than f of x? So just put in a few questions to answer this one. We have f of x is looking like this. This is the line y equals f of x. It goes through this point here at 1, 16. It goes through this point here at 3, 4. This is the line y equals f of x. L of x is a L of x is a secant line that passes through that curve at these 2 points. So it passes through the 2 curves. Is L of x always greater than f of x? Is it always less than? It's only greater or less than in certain intervals. It is greater than in the interval between the 2 points. Why is it greater than the function in the interval between the 2 points?
Because the graph is concave on.
Because the graph is concave up. If the graph was concave down, it would be the reverse. Now, often your questions in the modeling things, they revolve around that. So you can't just argue it's because it's concave up. If it's concave up, it will be greater than between the 2 points. This is because this red line has a constant rate of change, which is less than the rate of change of the function at this point, which is why at this point the function decreases a bit faster. The red line has a rate of change which is greater than the function at this point. The rate of change has one that's the same, and this is the function around about that point there. That's why they have the same. So you need to talk about that a little bit more, and obviously mention the concave one. All right.
So L of x is greater than f of x in the interval
Between
when
1 and
x
3?
is between 1 to 3 because the graph is concave.
Yeah.
That's
Yeah. Okay, so we're going to have, next week, we're going to do a FRQ1 question for you all. The FRQ1 question is going to give you two functions, guaranteed. The functions could be presented like this as a rule, could be presented like this as a graph, or the third option is it could be presented as a table of values. A table of values. You will get two functions presented in that form. Typically, we do a functions composition. Part AI is functions composition. Find f of g of x, or g of f of x. So this one is, we need to find g of f of x. So, sorry, we need to find g of f of, what's the value? -2. We need to find g of f of -2. So we start by finding f of -2. F of -2 brings us up to this point, we go back to that point, we get a 1. So that becomes g of 1. G of 1 means we put it into this function. So this is equal to 3 bracket 1 over 1 plus 2. That's going to give us 4 over 3. Now, it says here in the question, read the question carefully. We have to give it as a decimal approximation. So if it tells you you have to give it as a decimal approximation, giving the exact answer will not be sufficient to get the point. You will not get the point for 4 over 3, even though that's a better answer. It's asking for this as a decimal approximation, and we have to write it to 3 decimal places. A lot of you are still writing it to 3 significant figures. It has to be to 3 decimal places on this course. Learn how to force your calculator to give you 3 decimal places instead of 3 significant figures, particularly on the graphing page. The standard setting on the graphing page is 3 significant figures. All right, find all the values of x for which f of x equals 1. I'll indicate those solutions. So we are looking where f of x is equal to 1. That means we have a line here. We have to find where this line crosses. Well, we already found it. There's this one point here, x is equal to -1, but there's a second solution here, x is equal to 2. So our answer here to this one is f of x is equal to 1. It implies that x equals -1, x equals 2. Okay, have a go at this question for a minute for yourself, and then I will do the question. Okay, so for part I, we are expected to show our working. So we have -13 is equal to 3x plus 1 over x plus 2. Let's start off by finding the answer. We have to algebraically show it. You just want to find the answer so you don't get it wrong. So what I'm going to do on this one is I'm going to show you a couple of quick techniques on our calculator. Mohammed A, watch me. I'm showing you how to use the calculator. Okay, so we open this one up here, and we put in our function 3x plus 1 over x plus 2. We graph it like this. We want to find where it's equal to negative 13. So what I'm going to have to do is I'm going to graph the line y equals minus 13. I don't see it because my x value is too low here. It's not low enough. So I'm going to double click on that and just send this one down to minus 15. And now we can see where the two lines intersect. If we analyze this graph and find the intersection, be quite careful over here just to get to the left. That's still in this interval around about there. And then scroll across like this. And we can see the value now is at minus 1.69. Notice that's 3 significant figures, and there's not 3 decimal places. To change the setting on the graphing part of the calculator, we have to go into Menu, Settings, and change from float 3, which is the standard feature, to fix 3 here. And then this will give us minus 1.688. Another way to solve this one is here on this page. Once you put the graph in, we can press Menu. We saw there on the graph there was only one solution, so n-solve is a very suitable technique for this one. And we can just n-solve f of 1 of x is equal to negative 13, solve for x, control enter. And we get minus 1.68. Notice this is in 4 decimal places. If I round up from that number, notice that 5. That 5 could have been pre-rounded, so I can carry a rounding error forward twice. So it's best just to press document 7.2 and change this from float into fix 3. Like minus 1.68. This is the answer I have. So I'm going to rearrange this equation like this. I'm going to open up the bracket and move it around. This is going to give me minus 26, minus 27 on that side, and it's going to give me 26x on this side when I just rearrange it. So x is equal to minus 27 over 26. Let's check whether we got that right. So minus 27 over 26, control enter. Oof. Did I get something wrong? The answer could be wrong here. Let's see. What did I do? Oh. Well, let me see what I did. Oh, I see what I did. I did too many, basically, I did too many steps in one go from here to here. So let me do that a little bit slower. Make sure I don't make mistakes. So I get minus 13x plus 2 is equal to 3x plus 1. And then, oh no, still making mistakes. Minus 13 times 2. Negative 26. Rearranging this around, I'm going to get 16x and minus 27. 16x. So x is equal to minus 27 over 16. Try that one on my calculator. Minus 27 divided by 16. I've already checked. I know that's the right answer. It's equal to minus 1.688. Decimal expansion, 3 decimal places. I need to do the limit value now. This one's a little bit easier. Need to move this one down. So it tells me that I have to determine the limit behavior of g as x decreases without bound. So for part 2, notice me telling the examiner which part I'm answering by writing the I and the I. Stick to that. So to write this, we need the limit as x approaches negative infinity, as x decreases without bound. Notice that the x approaches negative infinity is under the word lim, only. This acts as like a function on this, g of x. Notice I'm writing g of x, not f of x. Why? Because I'm doing g of x. Limits aren't always f of x. Don't just get into that rut of always writing f of x at this point. You'll get it marked wrong. And then we need to work out what the value is going to be. We can see what the value is going to be easily. We saw it on the graph, but you can see it here. If the degree of the polynomial in the numerator is the same as the degree in the polynomial in the denominator, then the end behavior is the coefficients, the two lead coefficients. Sorry, this is a 1. So it's going to be 3 over 1. If the degree of the numerator is the same as the degree of the denominator, then the end behavior is the ratio of the lead coefficients. So this is 3. Visually, you see it here in this graph. We see it, and we can check it. So I think it's going to be at 3. Put in the line y equals 3. And you can see that sort of asymptote behavior happening there. Okay, determine if f has an inverse. Do we say yes or no? We say no. You cannot say no. You must answer with a sentence to explain clearly what you're talking about. No.
F of x doesn't have an inverse.
F has no inverse function. Do not answer as a single word, no. Do not start explaining why. That's part 2. Try and separate the two out. No, f has no inverse. Give your reason for your answer based on the definition of a function. So this one's you found this one a little bit tricky because we have learned that a function has an inverse if for every output there is a unique input value. But many of you were not able to turn that sentence into the opposite, into the negative. We say it has an inverse if every output value has a unique input value. So we have to turn that into a negative sentence. So why does f have no inverse? F has no inverse because, now you can't say because every output value has a unique input value. You say the opposite, because some output values do not have unique input values. Such as, so give an example, if there is in this one. It's very easy to, proof is really hard to do. Disproving something, super easy. Give one example that disproves it. So what would the example be that we would give? We would say that f of negative 2 equals f of 1 equals, f of negative 2 equals f of 2 equals 1. That's the one that we found earlier, isn't it? Although I wrote the number wrong here. It's 2. That's the correct one. I wrote the number wrong here. It's -2. I don't know why I said 1. So give an example, f of -2 equals f of 2 equals 1. Alright, let's have a go now at an FRQ2. So an FRQ2 is a modeling based question. You will have a scenario for this one, and typically part A is to find the function. Now make sure when you do this, part A1, you've put up 2 equations. Don't simplify the equations. Don't do any simplification. Don't grab for the answer. Put up the functions, the 2 equations in I, solve them in I. Have a go at this one now. So with this question, try and figure out what is the dependent variable, what is the independent variable. Your sort of dependent variable is this distance from the epicenter. The intensity is your the distance from the epicenter is your independent variable. Your intensity is your dependent variable, your y variable. Then dig through here in the data and find your coordinate points. So start off by finding your 2 coordinates. So at the epicenter, the distance is 1 kilometer, so distance is an x value, that's a 1. The intensity is 7. At a distance of 10 kilometers, the intensity is 5. So at a distance of 10 kilometers, the intensity is 5. So write down your 2 coordinate points. Make sure you analyze from the wording which one is the x, so-called x, which one is the so-called y value. Write them down. Have them clear on your page. They will help you make your equations and a few different parts of the problem. So the first one is going to be 7a minus b times ln 1. 5 equals a minus b ln 10. That's it. That's it. We need to solve this one now. So 7 equals a minus b times 0, because ln 1 is 0, which means that a equals 7. Then we can put this in and we get 5 equals a minus, 5 equals 7. 7 minus b ln 10. So 5 minus 7 is going to give -2 is equal to minus b ln 10. So b is equal to 2 over ln 10. Use the exact value in your calculations. Pull up a decimal approximation. So there is your exact value. Control Enter. There's your decimal approximation. 869. 869. Here are our answers. Okay, so this is like our warm-up question, our do-now question. This is the same thing. We find the average rate of change, we find the secant line, and then we give our reasoning. So have another go at it now, based in this modeling question. Give you a few minutes for that one. Okay, so what have we got this time?
Nice one, John.
We need to find the average rate of change from 1 to 10. Now, hopefully on your page you have these two, 1,7, 10,5. 1,7, 10,5. I said to write these down on your page, so you've got them there. We need to find the average rate of change between those. So the average rate of change is equal to, and y2 minus y1, x2 minus x1. It's amazing how many people are still writing the x values at the top, getting it the wrong way around. Have your coordinates written down. Make sure that we get it right. We've got 5 minus 2 over 10 minus 1. This is going to give us minus 2 over 9. Notice in the question here, it doesn't say give your answer as a decimal approximation. So we can use this value. We can use this value. So just double check reading your answer. Does it want a decimal approximation, or can we have an exact value? If you are using the value in subsequent calculations, I recommend using the exact value, even if it asks for a decimal approximation. Use your exact value moving forwards. It's better math. Use the average rate of change to estimate the intensity. So this is your secant line, and I'm just going to look at the next bit. So in the next bit, it calls the secant line A of D like this. So A of D is equal to y1 plus m bracket x minus x1. So we can use either of these two coordinates on this one. I'm going to use this value here. I'm going to use this one here. So I'm going to put in 5 minus 2 over 9 bracket x minus 10. So use the average rate of change to find an estimate at 20. So if we want a 20, we are going to have 5 minus 2 over 9 bracket 20 minus 10. So have the calculator help us on this one. 5 minus 2 over 9 bracket 20 minus 10, 10. We get 25 over 9. Control Enter. So this is equal to 25 over 9. 25 over 9.
Because we use the
This is equal to
sir?
2.778. 2.778.
If I put in negative 0.222 instead of negative 2 over 9, and I got a different answer,
Because you're making a rounding error.
Okay. But I made it like, I just took the exact value of negative 2.
What you want to do for this type of work here. So if you're copying the number down for the decimal expansion, where was the value? Oh, I didn't do it, did I? Let's say on your calculator, you get minus 2 over 9. And then you press Control Enter, and you get minus 0.222. If you write that down on your page, don't type that in. Don't type that in. So when it comes to doing this calculation, 5 plus, and we want this answer here, go up to the answer like this and press Enter, and it will copy it down, and it will copy the exact value down instead of typing it in by hand. Go up and copy it down, and then times 10, then we're getting the right answer. So you're making a rounding error if you copy that, if you write down on your calculator minus 0.222. So use the exact value 2 over 9, minus 2 over 9, or go up and copy the value down. Another technique to use, if you're finding it difficult to copy more than one value down, we've got this value here. You can always press, we want you to Control store. We could store it in A. We put a little. So we take the last answer and we store it in a variable such as A like this. So then if we wanted to do 10A, we get the exact value. Okay, let A represent the intensity and explain why. So on this one you need to, if we graph it, we graph the two functions. We've got a function doing this, and then we have a secant line doing that. It's going through these 2 points here and here. This one is at 10, 5. It's doing this. And it wants to know, so the black one is A of D, the blue one is F of X. No, I of D. It wants to know if for values bigger than 10, which is this one here, is to explain why A of D is greater than I of D for all values greater than 10. It's not, it's less. Okay, it's less than for these values. So we need to, but whether we're explaining with which direction it is. Notice that the black line is greater in the interval between them, and it's less in the interval after 10. So you have to mention two things. You have to mention that it's concave up or concave down, and you have to mention that it passes through these 2 points, and then in this case we have to talk about what happens after that point. So firstly we'll talk about I of D is concave up. AD, A subscript D, passes through 1,7 and 10,5. As A of D has constant average rate of change from 10,5, it will decrease faster than I of D. So it will always be less than I of D for D greater than 10. So what I'm trying to emphasize here is we're not just saying it's concave up. We have to talk about the intervals. Because you see how the intervals are important. From 1 to 10, the black line is above. From 10 onward, the black line is below. Without talking about those two intervals, you are not fully explaining it. Take a minute now to copy down my reasoning here. So I of D is concave up. AD passes through the 2 points. As AD has a constant rate of change, from 10,5 it will decrease faster than I of D, so it will always be less. Okay, so we found the model in the first part. We've got this 2 over ln 10 and 7. So we're going to use that model, and we want to find when the intensity, which is a y value, is equal to 3.5. So we've got 3.5 is equal to 7 minus 2 over ln 10 bracket ln, ln d. So let's start off by taking away 7 from 3.5. What do we get? We get minus 3.5 is equal to minus 2 ln 10 times ln d. Then we want to divide through by this minus 2 ln 10. And that divide through by that, that will give us 3.5 ln 10 over 2 ln. So the inverse operation of ln is e to the power of. That means d is equal to e to the power of this whole expression. And we just write this expression as 3.5 ln 10 over 2. So we'll do it twice. I'll use my expression and see what number I get, and then I will numerical solve and check that have I messed up. The calculator's there to help you in that. So e to the power of, and then I want a little fraction, 3.5. 3.5 ln 10
Thank you for the pen.
over 2.
Thank you for the pen.
Control enter. Syntax
Whoever it
error,
is, thank you for
nothing.
the pen.
Got that decimal point. Control enter. 56.234. So let's also try n solving the original equation here. So menu, algebra, numerical solve. 3.5 is equal to 7 minus 2 over ln 10 times ln x. Solve for x. Our two numbers are the same. I'm happy with my answer. 56.234 equals 56.234. All right. Finish off today. Make a list of 5 key things to review that you feel you need to review to be prepared for your FRQ for next week in the mock.